Hello everybody, I'm NINIAN KUJUR from Sri Venkateshwara College, University of Delhi, Delhi. First of all, I would like to thank the organizers for giving me an opportunity to present my work. So let me start now. The topic of my presentation is on some examples of generalized directed association schemes obtained through computer search. So let me first give a brief introduction to association schemes. Association schemes were first used by R.C. Bose and his school in the context of experimental design. The algebra of association scheme was constructed by Bose and Messner and is known as Bose-Messner algebra. Next we define association scheme. Association scheme was defined by Bose and Shimamoto as the set C of non-empty relations, say C0, C1 up to Cm on a finite set X, satisfying the four conditions as mentioned in the slide. The first condition says that union of all the Ci's is equal to X cross X. The second condition says that C0 is equal to the diagonal of X. The third condition says that all the Ci's are symmetric. And the fourth condition says that for all ijk in the set 0, 1 up to m, there is an integer pijk such that for all x, y and ck, the number of elements z in X such that xz belong to Ci and zy belong to Cj, that equals to pijk. Now next we define adjacency matrix M of the relation Ci. The adjacency matrix M with entries A, U, V with respect to the relation Ci is defined as follows. We take AUV to be equal to 1 if UV belongs to C and 0 otherwise. The adjacency matrices of an association scheme form a basis of an algebra called algebra of association scheme. Association schemes are also defined by the adjacency matrices A0, A1 up to M of their associate classes, which have the following properties. The first property says that summation of all these AIs equal to the all-one matrix G. The second property says that A0 is equal to the identity matrix. The third property says that AI is symmetric for all I. And the fourth property says that each matrix product AIAJ is a linear combination of all the AIs. Now next we define coherent configuration. Coherent configuration is a generalization of association scheme and was defined by Hickman by weakening the second and third conditions of association scheme. So from the slide we can see that the second condition says that there exists a subset A of C, which is a partition of the diagonal. And the third condition says that for every relation Ci in C, its converse is also in C. The first and fourth condition remain the same as of association scheme. Here also coherent configuration can be defined by adjacency matrices of its classes. So if A1, A2 up to M are adjacency matrices of C1, C2 up to Cm respectively, then the axioms take the following form. The first one says that summation of all these AIs is equal to the all-one matrix G. The second one says that there is a subset of the set of matrices A1, A2, Am which sum to the identity matrix. The third one says that each element of the set of matrices A1, A2 up to Am is closed under transposition. And the fourth one says that Each matrix product AIAJ is equal to summation Pijk AK, summation varying over K, where Pijk is a positive integer. Now we come to the definition of generalized directed association scheme. Generalized directed association scheme was defined by Singh and Maji, which is a generalization of coherent configuration by removing the second and third condition of coherent configuration. So here basically we have got only two conditions. The first condition says that C is a partition of X cross X, and the second condition says that for all ijk in the set 0, 1 up to m, there is an integer Pijk, so that for all x, y and ck, the number of elements in X, so that xz belong to Ci and zy belong to Cj, that equals to Pijk. Now, generalized directed association scheme can also be defined by adjacency matrices of C0, C1 up to Cm. So if A0, A1 up to M are adjacency matrices of C0, C1 up to Cm respectively, then the axioms take the following form. First one says that summation of all these AIs equal to the all-one matrix J. And the second one says that for all ij, the product AI Aj is equal to summation Pijk AK, summation running over K, where Pijk is a positive integer. Now this slide gives the details of the exhaustive examples of generalized directed association schemes of orders 2, 3 and 4 up to classes 4, 4 and 2 respectively. Till date, no exhaustive examples of generalized directed association schemes have been generated. So this work is new in that direction. Let me also mention one more thing, that beyond order 3 class 4 and order 4 class 2, outputs could not be generated even after running the code for 1 week on a supercomputer. I'll be now displaying the outputs obtained, but due to time constraint, I'll be displaying only the outputs for third order and class 4. There are 9 outputs for it. So these are the first two outputs. This is the third and fourth one. The fifth and sixth. This is seventh and eighth. And this is the last one, the ninth output. Now from the outputs obtained, we can draw some conclusions. One of them is that we can generalize some of the outputs obtained to nth order for any n. For example, consider this particular example obtained for order 3 class 4. This can be generalized to nth order for any integer n by taking the 4 matrices as follows. We can take the first matrix as follows. We take the first row to be defined as follows. The first n-1 entries to be 1 and last entry 0, and rest all the entries in the matrix to be 0. Then we can take the second matrix as follows. There we define the first row as follows. The first n-1 entries to be 0 and last entry 1. Rest all the entries in the matrix to be 0. The third matrix, we take the first row to be 0 row and the last column to be the 0 column, and rest all the entries in the matrix to be 1. In the fourth matrix, we take last column to be defined as follows, where first entry is to be 0 and remaining n-1 entries 1, and rest all the entries in the matrix to be 0. So similarly, some more observations can be made, but due to shortage of time, I have translated here only one such observation. With this, I end my presentation. So these are the references. Thank you very much.